In this 100% fusion video, I will show you how we can build this spatula. Well, we have actually one element that is bent. It's only a piece of flat metal. This is something we can easily create with the tools Fusion has. We just extrude it along a curve. We don't have to bend, for example, a more complicated body like the handle. Before we get started, again inside the same Eating Cooking Utilities folder, there is also the sketch blue spatula with all the dimensions. As a small tip, and generally this makes really sense before you are going into any serious modeling, Blender, CAD, whatever, take the time, make yourself to scale correct drawings so they all have the same scale, so you can get an idea of how all these objects really will feel when they have proper dimensions. Because when we do quick sketches and explore ideas, very often we ignore dimensions, and then when we go into 3D and build it, it all starts to look quite different. Okay, so let's get started. With the spatula, we have kind of like three elements. We have the tip, we have the bent metal part, so the core, and then we have the handle. So three problems, and it makes sense step by step to try to work on everything. So we will start actually to work with the head. So we can make a sketch, and for example, let's create a rectangle. I'm in millimeters. Okay, so this one we will dimension to 76, and this one we will dimension to 50, let's say 50. Okay, and I want this one to be perfectly centered to my sketch. So to do this, we can create a point right at this midpoint, and then we could say, well, this point coincident to the sketch center. Boop. There. So the sketch also turned white, in case you ask yourself why. When you go to preview, you can turn on sketch. And this basically gives colors to your sketch, and when everything turns white or parts turn white, that means these are actually fully constrained parts. And you see also here the sketch now has a pin. This means there's nothing in the sketch I can drag and deform the sketch. Okay, so perfect. Let's go back. And there you see I have now the next two problems. First, the roundings, and then I have actually this chamfer. And actually, you don't see this in the sketch. The third problem, the handle has to be in the center. So you have to be aware of that. And as I mentioned before, always keep your sketches as brutally simple as possible. You will be happier because Fusion can adjust these sketches faster. The more complex a sketch, the slower the adjustment will be. And let me go back to the sketch. A lot of functions like edge roundings, and that we can simply do via fillets, but not sketch fillets, but the fillet feature. So we can put all these features then into the timeline and also turn them on and off. That's the main reason, or the second main reason. So speed and flexibility. So everything has to be 4 millimeters. So we can extrude U 2 millimeters, but actually both directions. Bang. Okay, good. So there's now a chamfer and the edge roundings. So what would be the best step? So let's maybe go with the edge roundings. U and U will be 5 millimeters. Then this one will be 20, and this one will be 10. And maybe I want to set those to there. I like those qualities better. Okay, perfect. And now I would like to chamfer everything. So I can select this upper part. There are two types of chamfers. So, or not two types, but what I mean is chamfer with an even value. or for example, two different values. So let's say this is 3 and this is 2. And there you see that actually we have a little bit more play with it. So it's up to you to decide which one you want to use. And you see, if I do that, then also this edge gets chamfered. That's not really actually what I want. So this top area is all good. This is kind of junk. So what can I do? Well, let's maybe go to here, and can we actually chamfer maybe certain edges? Let's say we chamfer chain select off this one, and this one, equal distant. Okay, let's move this one down. So maybe to there. 3.5. So I think this is what distance? 0.5. Yeah. This will be tied to round later, but let's see what happens when we bring this one over. Oh, we get this junk. So not ideal. Well, this one actually doesn't really make sense at the end, and because then you see the way with the fillets, it doesn't really work well. So what happens if we say, well, what about you, you, and you? There, you see, this actually works already much better. See, not too bad. Okay, so that's one strategy. Okay, and then we could go use another fillet and say, what about you, and you, and you, and probably you. 0.25. Cross fingers. Ooh, the software does it. Let's take a look. I don't like this fillet. Let's go to this option. Okay. What about 0.5? That's a tricky part there. 0.4, 0.3. Yeah, 0.3. The 0.3 works well there because this is a very small area which we all fillet at the same time. Okay, so that's one option, but it's kind of like not a really very good one. So let's take a look at a different strategy. So we go back to chamfer, and this time we chamfer just this, and this. So from a side view, this is chamfered, but this remains flat. Okay, so now we can go ahead and say fillet, please, this and this by 20. And let's see, and we get this. Also not really great. Okay, so you see we get this other stupid problem. What happens if we only fillet this one with 20? And then it looks like this. It's also kind of junk. So, what can we do? Well, let's try this one. What about when we round this edge, and then we round this edge, but these back edges we keep empty, and then we fillet the stuff. Here we have to update the feature because these edges here aren't actually included. See, this edge is naked, and that actually now will do it. So you see, it's a little bit of logic. Okay, perfect. So this is actually, yeah, this is what I want. So now I can go ahead and this one maybe with 10. Ooh, way too much. 5, not 15. Too big. 2.5. This is good. And then maybe you and you. I know the distance between the two blue lines is 0.5. Can we do this 0.5? Fusion is working. And I hope I didn't crash it. Nope, it doesn't work. That's too complicated. 0.4 probably will fail in this case as well. Yeah, okay. So I know properly with 0.25 I will do it. So if I zoom in, maybe take a look from the side. So that's the way how it looks. But what happens if we only select this one and say 0.5? Look at that, 0.6, 0.5. Okay, good, interesting. Now here we have a new edge, 0.25. There, see, there we have it. Okay, perfect. Good. So with this one being 0.25, we might actually run into an issue later when I want that other edge to be rounded. So let's see how big we can push this one. 0.4. Ooh, not really good there. So maybe we say 0.3. I don't want these edges to get too close. So when this is 0.3, then I know this edge, maybe 0.25, should work to there. Okay, goody. So handle part is done, and that is very good. And yeah, okay, nice. So it's actually at this point now time to take a look at the metal part. So with the metal part, it properly runs somewhere in the handle, and you see it comes down and then goes horizontal and goes into the tip part. But it has to be centered, and that is actually why I made the sketch on the ground plane and then offset everything 2 millimeters top and bottom to get 4 millimeters. So let's see what we can do. So this sketch is actually only on the ground plane, but I have this point that's actually kind of like the world center. So I can make a new sketch, and this time I do it from the side. Maybe this one I call tip. This is handle, or yeah, handle metal. Nope, we call this one metal. You will see why. So we can see 45.8 to the right and then 62 up. So from the center, because everything is lined up there, I can make a line, and I make a line. Perfect. And I already forgot the values, 44.8 and 62. 62 and 48. That's embarrassing. I forgot this one again. 45.8. Wow. There. Okay. Goody. So this is kind of like left to right and the height. And then here I have 4 millimeters and 0.8. Kind of like to describe a little bit how the metal part later has to be bent. So I can go ahead and make this one 4 millimeters up and 8 millimeters to the side. Dimension, okay, and all those are just guidelines. And I will with X turn them all into construction lines. Perfect. So there will be another tip now. See, I have this line, and actually when I shoot a line from here, it hits the tip and also goes into the back of the handle. So I want to draw a line from here through there to somewhere else. So how do I find this point? I can press S and type in intersect. So intersect. And you see I show the sketch. There's a red dot. Click and then from tip sketch, where it intersects with this line, I find a point. Perfect. Now I can go ahead and draw a line to there. Great. So this is kind of like my array. And then I can draw another line. This is, for example, now the direction of the handle. And this one I would like to be parallel. There. So parallel works because they all are fused together at this point. And maybe this one I can give a line, let's say 120. Okay. This one I don't need to give a line because the start is given by the tip drawing, and the end is given by this line. Okay. But with this done now, I actually have all the geometry to create my spline. This is also, let's hide this one for a moment. V, I cannot hide it. I thought I could hide it. Maybe that took it off. V, nope. The reason why I created also two lines is simply I can measure this as a line, and I can now create a new spline being tangent to this line. I will also create a small line here, make this one construction. This can be of any length, and now comes the fun. So S, click on the spline, or type in spline, and maybe there. Whoa, what did I click? Oh, I clicked the arc. I meant click the spline. Click, click, and click. Okay. So this end of the spline I want to be tangent to that. So tangent U to this one. Okay. And then this end I want to be tangent to this line. So tangent U to this line. So you see you need incoming and outgoing lines for the spline to be, well, tangent to. Okay, so now I can select this sketch point, hopefully, and drag it. Okay, there, I can drag it out. Maybe with D and this point, add a dimension to it, maybe 27. And what about here? Oh, okay, maybe we can leave this one for the moment. So what do I build with 30 or 40? No, this is too much. 35. This bends too much to the left. 30. Okay. So this comes down, blends in if I want. I could even make this one straight vertical. Then actually this one has to be 28, 20, so it comes down, becomes straight vertical, and bends over. So I don't know if maybe this was a good idea. So we can deactivate this one, right mouse button click, and then maybe just control everything via the dimension. Nice flow. Okay, good. So this is now actually our metal part. So for the metal part, we need a cross section. Let's go to here. I have it somewhere. I thought I had it somewhere. It's probably 2 millimeters, and let's take a look. What's the width? 10 millimeters, I think. So U to U, 2 millimeters. Okay, good. So we need to create the sketch and connect it to the spline. So construction, plane along path, along this path. We can keep it maybe for the moment where it is. Okay, let's make a sketch on this new construction plane. Then let's go to rectangle, center rectangle, click, drag it out to whatever. Press D to do the dimensions, 10 and 2. There we are. Okay, so this is maybe metal profile. To create now the geometry, we can use the sweep command, because this cross section we will sweep along this path. Can we add, actually make this a little bit longer? No. Okay, so ooh, my mouse is kind of funny. Hold on 1 second. There, let's go back. So I can slide it actually on that curve, but I can unfortunately not maybe add more to it. But this is not really a big problem, because I made this one tangent and tangent. So now I can go ahead and say this face is pretty much horizontal, vertical. And you see I can simply extrude it out. Let's say 20. There. Let's take a look how far it goes in. There. Okay, this is good. Maybe not. It's kind of short. So 40. Body we want to turn off. Okay. There. And for example here, this one again, because the sketch ends here being perpendicular to the face is perpendicular to this line, because the sketch we set tangent to this line. I can simply extrude this one out, maybe, let's say maybe 80. Okay, good. Let's double check. Let's go to the side. Let's zoom in, and there you see this line, they seem to be all parallel. Yeah, okay, perfect. If we would have to bend this extrusion at the end, then the current process wouldn't really work well. I think then this cannot be a construction line, but it all has to be connected to the spline. But in our case, this actually worked really well. You can see again, everything is about shortcuts. Not shortcuts to cheat, but to, with the least amount of tools, get the maximum amount of output, so that the computer system that generates the geometry has less work, which makes it all simpler. Kind of like what Einstein means, with more manageable. Not simpler with what I very often hate, being more boring. Okay, so this was problem 2. Now we have to do problem 3, the handle. Okay, so a new sketch from the side. Let's go back for a moment. And the handle has some interesting problems. We have these depressions, and then we have this hole there. But we're creating the sketch all from the side, and here I will show you something. Let's go to there, and you see actually this hole, I made an extrusion, and then that object I rotated, and then I cut it out. Because I want my sketch from the side to include everything, including that hole. So let's go back to here. Let's take a look at our drawing. So we have a circle at the end. We have something at the beginning. Here we have a circle, another circle, and this whole thing is 120 millimeters wide, 25 millimeter for the flat part. So and then there we have this ellipse, and I think this is 6 millimeter and 18 millimeter. Okay, so let's go ahead. We made this new sketch, and I will project, or better actually 3D include this line, and turn this one off. So I have actually the beginning of my metal and then the ray. With this one now I can work. So where do we start? Easiest one is here, 6 millimeter and 6 millimeter. So I can draw a line from there. I can rotate it till, for example, it's perpendicular. There, 6, enter. And the perpendicular constraint wasn't added, so here let's make sure this is perpendicular. Okay, perfect. So, and then there is an 18 millimeter ring. Okay, so let's make the circle, and there, from there to there, let's make an arc something. Dimension U to U there. This should be 6 millimeters. The radius or the center of my circle should be on this line, so coincident this point on this line, because now this actually comes down and this angle is 180. And I could give this a radius, or I could also say U to U. What's the spacing? For example, 18 there. And it would be 9, the radius. This is the dimension. Okay, goodie. Let's go back. Let's double check for the moment. I want to see. So this is radius 12.5, 12.5. Oh, I use a different radius. Okay. So there and there. So 12.5. Okay. And you saw that at the end we have exactly the same. So I can do the same thing here. This one coincident to here. There, double click. I want this one to use. So it's the same. And this is 120 apart. So right click and aligned. There, 120. Ooh, right at the end. Oh, perfect. So I want to turn this one off for the moment. And right click, show dimension, make this one 140, simply so it's a little bit wider. Okay, good. Let's go to here. Yeah. I did not like that this point and this point were at the same position, because if I later want to make this longer or shorter, I need more material to work with. Good. 25 millimeter of a parallel line to this line from the tip of my circle, and then it swoops. So let's make a line. Seems like the midpoint there. And 25. Okay. And then this one should be parallel to this line. Okay. What about this one we delete? You see we can move this to where we want. But now this point should be tangent to there. So tangent U to U. But now, it doesn't really connect. But I could say coincident this point to the circle or arc. And there we are. Okay. S, call the spline command. Click and click will be good. This case here, I want to use smooth this one to there, so I have a nice soft transition. Here actually these handles I will pull out because I want these handles to be parallel to this line there, and then click this one, and my handles here I can pull out. So there you see I can start shaping that transition nicely. Maybe a little bit smaller. with this one point selected, deselect the other point, right click, aligned, and we can give this a value 8. Okay, and maybe here we want to give this a value 24. 8 is very tiny. No, maybe like this. No, this is good. So perfect. So we could say you and you be the same, and you double click and you be the same. So when I say this should be 4, you see everything updates. 6. Perfect. Okay. You see I have this element here and there because I actually would like to cut something there out later. Stop sketch, and there you see how they overlap. So how do we do this? This ring has a radius of 12. Okay, here's the ring center. So let's draw a line. And this line X, so it's just a ray. Now I will go ahead and go to diameter, click on this one, here, this one I will delete, maybe bring this down a little bit. Actually I want this point to coincident on this line, okay, and hue dimension with D, double click, be the same like this one. Oh, that's interesting. 12. Why is this actually smaller? This maybe multiplied by 2. Yeah, that was it. That's actually an arc. And before I added actually the diameter. And I set diameter to be 12.5, which was half of it. But in this case, we need to adjust the formula to this one multiplied by 2. Okay, this we would like to intersect, so we could say, what's maybe the easiest way? U to U, aligned dimension, what about 25? Okay, then they touch. That makes sense, 25 and 25 is each basically the diameter. So center point to center point, 23. Okay, maybe 24. Oh, sorry, 22. So it cuts in more. Okay, good. This actually makes one problem already evident. If later we take this circle and make a sphere and cut it out of this circle, you can see that the left and the right side are not the same. So I will delete this perpendicular constraint and I will add an angle constraint and then say instead of 90 maybe 88. So you see I'm rotating it slowly. 85. Yeah, and that actually 84. That seems to be good. Okay, perfect. So last element that is left is actually in the sketch the opening. So 18 and 10. Okay, so this is actually an ellipse, so we can use the ellipse tool. So let's see, U, repeat ellipse, U onto there and up. Okay, so dimension this line, that should be 10. And now this basically should be there. What again is the width of it? So 18. So this should be 18. Okay. And now I need to figure out how do I get this one actually to there. So you see this point is actually linked onto the line. So I could say, you know what, you should be coincident to the center point there. Perfect. Okay. So let's see if we make this 20, and you see it grows actually towards the tip of the handle, not the back. And 5, yeah. Goody. Okay, our sketch is so far good. So this all makes sense. Maybe let's play a little bit with the flow here, maybe 10. Okay, good. So how do we construct everything now? The main handle is actually a huge revolve object. So we can go to revolve and say you plus you, and also this stuff revolve along this axis there. Number 1. Perfect. And now it's time to work on the tip area. So how do we do this? Let's take a look. This is actually a center axis, so I could say rotate, so revolve. This whole part is unfortunately 1. I want only half of it, so I can go back to the sketch, and this one with X I turn back into a normal line. Okay, because this should not do anything. Now I can say revolve this one and this part along this one. Okay, great. And I would like this one to be mirrored over to the other area. So I could say, hey, there's a mirror command. So mirror this one along. There is no plane. Well, we have to create a plane. Plane at an angle, select this line. There's our mirror plane now. So now we can go to mirror you along this plane there. Perfect. Good. The rest we don't need anymore of that plane. Okay, so last element left is actually extruding this one here out sufficiently overbuilt symmetrically, both sides, new body, so it's not joined. And now I would like to rotate this one. So let's turn all the stuff off, and then we can go to move and see, we have to figure out where do we select it. Maybe there. But the rotation is not really ideal. So let's maybe set the pivot point. So the pivot point we set to there, and we want to rotate along that axis. Unfortunately, set transformation. I have to see what's going on. Should be able to rotate the pivot point as well, I think. So let me pause for a second and then I will be back. Okay, I started figuring out what was going on. So we do the same object, set the pivot point, then I will hide my object for the moment, and I move my mouse to here. And the problem is you could actually click on the ellipse, but I actually want to make sure that this line here I have selected till it snaps to the point, and then I can click on set pivot point, shoot, and then rotate this one so it matches up. Okay, now this is actually, how could I say that? An engineer would say this is not the best way to do it. Technically speaking, this is also correct because I more eyeballed something, but we're dealing here with an opening. If I'm off by 0.4 degrees for something like this, it doesn't really matter because it's not an axis or anything. Okay, so then I can click on OK, rotate my view, and then here rotate this one 90 degrees. And there you see, it all perfectly fits. Good. Okay. So let's show everything what we have. So this is actually our tip. This is the metal part. And now we have to do all the Boolean combinations. You cut with this one, and this one. There. So this is now our handle. Now we can go ahead and say combine U minus U but keep, and combine U minus U and keep. So I have all these spaces actually for the metal rod cut out. At this point now, the only thing that's left is maybe working on those parts here, maybe 1 millimeter, 2, it's properly too big, 1 and 1, can make those all the same. This one here, 1, okay. And here and there, maybe I would like to have a nice soft transition. Okay, good. Oh, nearly forgot this one. So hold on, there's my metal part. So at this point I have to actually round also the edges here. 0.25, 0.5, no, let's say 0.5. Nice broken rounded edges, because this metal part is now rounded along all these edges, and if I use that geometry and cut it out of the tip and the handle, you will see that I get the same edge definition. So let's maybe see if there's something we can refine. The fillet is pretty tight to this part, so this is actually handle, right click, show dimension, 6.5. Perfect. Now see, that's the beauty of parametric modeling. Everything can be dimensions and set up. However, you see this also works very good only for designs that are actually suitable for that part. And the spatula is actually a pretty good example to show how everything can be nicely driven. Now, this video recording was also pretty fast and fluid because I did this already twice. One demo for another company and then for somebody who was interested. And it took me some time to figure out, for example, how to build the tip of the spatula correctly. And in this video on purpose, I showed all the possible trials you have or you would come up with till at the end I showed you then which would be the best one. So also there, this parametric stuff is very fast if you really understand it. So this goes back to, before you really start modeling, sit down and think about how can you construct it, or what would be the steps. Don't just start building something, because you can end up that you create a structure in your timeline which then require you to restructure it with the worst case scenario, maybe having to actually delete certain parts and restart from scratch.